Hello students and welcome. In this video we're going to go over section 3.3 on the addition rule, and we will also do some examples from the homework. Before we jump in, let's go ahead and go over some background information. So the addition rule is used when you are asked to find the probability that one or another event occurs. So the keyword here is or. So we use the addition rule when you're asked to find the probability that events A or B occur. And the important notation that you're going to see in this section is here. So P parentheses A or B close parentheses, okay? And this notation stands for the probability of A or B or both events. Here, the word or is understood to be the inclusive or, which allows for the possibility that the two events may occur together. And I'll explain what that means with the two diagrams here in just a minute. Okay, so let's go ahead and go back to the book here. So in this section, we learn how to find the probability that at least one or two events will occur. So probabilities such as these are denoted by the notation I just mentioned, and depend on whether the events are mutually exclusive. So according to the definition, two events A and B are mutually exclusive when A and B cannot occur at the same time. So that is, A and B have no outcomes in common. So when you see the word mutually exclusive, what that means is that the two events in question have no outcomes in common. And that's what these diagrams are attempting to explain. So if the events A and B have no outcomes in common, they're called mutually exclusive. So in other words, the two circles that represent the events A and B do not overlap. On the other hand, right, events A and B are not mutually exclusive, right, when the two events can occur at the same time, or if they have outcomes in common. Okay, you can see that that the two circles representing the events A and B overlap, and the portion where they overlap is called A and B. So as you read the section, I encourage you to view the study tips. So the study tip here explains what the word or means when we use it in this section. So like I said earlier, the word or will be understood to mean the inclusive or rather than the exclusive or. If you want some examples on what mutually exclusive or not mutually exclusive means for two events, right, go ahead and look at example 1. So let's go ahead and go on to the next page. And now we're going to talk about the formulas for the addition rule. Okay, so there are two formulas for the addition rule. The two formulas depend on whether the two events in question are mutually exclusive or not mutually exclusive. So if the two events are mutually exclusive, so if events A and B are mutually exclusive, okay, then the probability of A or B is equal to the probability of A plus the probability of B. So in other words, when you're asked to find the probability that A or B occurs and the two events are known to be mutually exclusive, this formula simply says that the probability of A or B is equal to the probability of A plus the probability of B. On the other hand, if events A and B are not mutually exclusive, okay, then okay, the formula looks a little bit different. So the probability of A or B is equal to the probability of A plus the probability of B, right, minus the probability of A and B. So remember, not mutually exclusive means that the two events can occur together, or in other words, the two events have outcomes in common. So what is the formula for not mutually exclusive look different from the formula for mutually exclusive. So let me try to explain that. Okay, so the formula says that the probability of A or B is equal to probability of A plus probability of B minus the probability that A and B occur together. Okay, so that's when they're not mutually exclusive. So let's look at that for a sec. So this is the diagram when the two events are not mutually exclusive. So probability of A would be the first circle. Okay, so if A occurs, okay, that includes all the events in circle A, right, including any events that where A and B overlap. Okay. Now, on the other hand, if event B occurs alone, that includes everything that occurs in B, all outcomes in B, and then anything that may happen in A as well, right? Any outcomes that B shares with A. So in other words, probability of A, you shade the first circle. Okay, probability of B, shade the second circle. When you do that, you shade the overlap region twice. Okay, so in other words, the overlap region gets counted twice. So to account for that fact, right, we have to subtract that in the formula when A and B are not mutually exclusive. Okay, so I think we're ready to look at some examples from the homework. Okay, question 1 says, determine whether the statement is true or false, and if it is false, write it as a true statement. Okay, so the statement is, if two events are mutually exclusive, that means they have no outcomes in common. Okay, so we went over the definition earlier in the video, so I encourage you to review the definition of the book and then answer the question on your own. All right, number 2 says, determine whether the following events are mutually exclusive, and then it says, explain your reasoning. And then it lists two events, A and B. So based on the description of those two events, you have to decide whether they are or are not mutually exclusive, and then select the correct explanation. So once again, I encourage you to review the examples in the book. If you need practice understanding the definition of mutually exclusive versus not mutually exclusive. Okay, so let's go to the next problem. Okay, so question 3 is kind of the same thing, right? It gives you a description of two events, and you have to decide whether those events are mutually exclusive based on the description. All right, so let's do question 4 together. So a physics class has 40 students. Of these, 11 students are physics majors and 13 students are female. Of the physics majors, 3 are female. And the question says to find the probability that a randomly selected student is a female or a physics major. Okay, so let's go back to the problem, right? So we have 11 students that are physics majors, 13 students that are female, and then of the physics majors, right, 3 of them are female. So for problems like this, it's helpful to draw a diagram. So according to the problem, there are students, okay, that are both physics majors and females. Okay, so the events of interest to us are whether the student is a female or a physics major. So those are the two events in question. Okay, because those two events can occur at the same time, they have outcomes in common, right? So because there are students that are both female and physics majors. Okay, when we draw the Venn diagram, right, the two circles are going to overlap. Right, so P represents the physics majors, F represents the female students, and then the part in purple here is where are the students that are both physics and female, physics majors and female. Okay, so once again, the problem says that that 3 of the students are both female and physics majors, so that would be the purple region here. Okay, so we're going to write the number 3 in the overlap region. Okay, and the problem also said that 11 of the students are physics majors. So the way that I'm going to label this is I'm not going to put 11 here. Okay, yes, there are 11 physics majors. Okay, but the way that I've drawn the diagram is that the green region would show only the physics majors, the way that I've drawn this. Okay, so if we know that there are 11 physics majors altogether, right, and 3 of them are physics majors and female, right? I'm going to put the number 8 here in the green part of the circle. Get in to indicate that, okay, there are 8 students there that are physics majors only, but they're not female. Okay, but if you add the 8 and the 3 together, you know that the total of physics majors would be 11. Okay, as indicated by the problem. So the green portion of the circle are those that are physics majors only, but not female. Okay, likewise. Okay, it says 13 students are female. Okay, so once again, we know that there are 3 students that are both physics majors and female. Okay, so we've already accounted for that. So in the pink portion of the circle, right, I'm not going to put the number 13, but I'm going to put the number 10. Okay, because that means that only 10 would be female only, but not physics majors. Okay, so hopefully that makes sense. Right, so to get the probability of a physics major or a female, let's go ahead and apply the formula here. So probability A or B. Okay. I guess one way to think of it is, okay, so it'd be a probability of P, okay, plus probability of F minus the probability of P and F. Okay, so if you use the formula, so the probability of a physics major would actually be 11. So there are 11 physics majors plus 13 female students, and then minus the 3 that are both physics majors and female. Okay, so 11 plus 13 minus 3. Okay, be 21. Okay, so 21 represents the number of students who are physics majors or female. Okay, and then there are 40 students in the class, so to get the probability in question, it would be 21 divided by 40. Which is 0.525. Okay, it's a little more than a 50% chance that if we randomly select a student from this class, they're either going to be a physics student or a female student. So 0.525. Okay, and we've correctly completed question 4. Okay, so that might have been a little confusing the way that I set it up, but in any case, right, to answer the question more directly, right, add up the number of students that are physics majors to the number of students that are females, and then subtract the number that are both, and then divide whatever that is by the total, and you have your answer. Okay. The way that I set it up here is I've partitioned, right, or separated each student by group. So physics only, which is 8, female only, which is 10, and then female and physics majors, which are the 3. So if you add those 3 numbers together, 8 plus 3 plus 10, right, you'll still get 21, and then divide that by the total, and you'll still have your answer.